Alright, so in this video, we begin a new chapter starting with section 3.1, the product and the quotient rules. Well, so far what we have done in the previous chapter is take the derivatives of very simple functions that can be differentiated using the general power rule, like let's see, something like f of x equals 3x squared. Well, f prime of x equals multiply the power by the coefficient in front of x, that's a 6, and subtract 1 to the exponent, and that's going to be 1. Well, so in this section and on, we're going to look at derivatives of functions that are somehow a little bit more complex than this. For example, we're gonna start looking at the product rules. That is, we're gonna have a function that has the following form: y equals f of x times g of x. So a very common misconception is, for example, if we had the function f of x equals 3x plus 1 times 4x plus 7. Well, we have the product of the functions, and a very common misconception is to find f prime and just multiply the derivative of the first function times the derivative of the second function, which is actually not the correct way to differentiate. So the derivative of a product of function is not the product of the individual derivatives. So it's gonna be a little bit more than just that. Well, so let's see, where is this going to be? What are we going to do here actually? So, um, so we're going to have a function like we mentioned before, a function of the form y equals f of x times g of x. The way we're going to check the derivative of this function y is number one, take the derivative of f, the first part of the function, but leave alone the second part of the second factor of the function, and then we're gonna add the derivative of the second function in the factor times the original first function. There's more ways to denote the product rule. Like the first function f left alone, differentiate the second one, plus g times the differentiated f function. So it's just different ways to denote, different notation. There's another one that has this little, or rather this big D, which means differentiate, and this subscript x, which means with respect x, and the same. So f times the derivative of g, so that's f times the derivative of g plus g times the derivative of f, where f and g are the two functions that comprise the form of of the given function. In the future, later when we get more used to finding derivatives, I will just go with this version, f prime g plus g prime f. But in the meantime, since this is the first time that we are going to look at this kind of derivatives, now we're going to use the original one of the original forms. So this is one of the other forms in which we are actually going to denote what we are doing. Okay, so let's find the derivative of the given functions right here by using the product rule. Well, an alternative to go over this derivative is to number one, distribute. However, if you think of all that distribution steps might take, it may not be the most practical way. Even though yes, technically we'll have to do that when we are done with this example. So this is what we're gonna do in this case. So dy um, dy over dx equals, okay, it's gonna be the first function itself, x squared plus 3x minus 1 times the derivative of x cubed minus 8x with respect x plus It's going to be the second function itself, x cubed minus 8x times the derivative of the first factor, in this case x squared, plus 3x minus 1 with respect x. So let's indicate it like this for now, because again we're doing this for the first time, but again later we're just gonna go this on the fly, f prime g plus g prime f in a more simpler way. All right, so the derivative of this function will be dy dx, which is, okay, the first polynomial which is left the same, x squared plus 3x minus 1 times the derivative of x cubed minus 8, which happens to be 3x squared minus 8, plus the second function, which is x cubed minus 8x times the derivative of this polynomial right here. All right, so in this case the derivative over here is going to be 2x minus 3. So we are essentially done with the calculus part right here. However, what this could be taken as a correct answer, well, I would have taken this as a good final answer if we were taking this exam in person. You know, what I would like to make sure here is that you are able to identify and how to use the product rule. However, our homework system might ask you to simplify this, and yes, this one, what we're going to do here may take a while, so we would have to distribute all this. That's going to give us, well, on the one hand, so that's 3x to the fourth minus 8x squared, and then 3x times 3x squared and 3x times negative 8. That's going to give us 9x cubed minus 24x. And last but not least, for this one, we're gonna have negative 1 times 3x squared, negative 1 times negative 8, which essentially changes the sign of everything here. So that's a negative 3x squared plus 8. We're going to do the same over here to distribute all this. So that's x cubed times 2x and x cubed times negative 3. And on the other hand, negative 8x times 2x and negative 8x times negative 3. So that will be plus x, actually 2x to the fourth, and minus 3x cubed. And last but not least, well, that's a negative 8x squared, or actually negative 8x times 2x, that's going to give us negative 16x squared, and then plus 24x. So over here we're ready to simplify all this by combining like terms. So that's what we're going to do here. Okay, let me rewrite all this. So that's a dy dx and dy dx will be, so what I like doing is to combine all the 4 powers with 4 powers. So let's see, 4 power, do we have another 4th power? That's another one right here. Cubes with 3 bars right here, and then squares, 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 first powers, and constant terms with just this with here. So for the 4 powers we have 3 plus 2, which is 5. Oops, change color. 5x to the 4th power. For the cubes, that's a 9. Minus 3, that's 6. And for the squares, that's a negative 8. Minus 3, that's a negative 11. And negative 11 minus 16, that should add up to negative 27 x squared. And for the first powers of x, that's negative 24 and plus 24, this actually cancel out. And let's just add this plus 8. And this is final answer. So that's how we use the product rule. Yes, I mean, again, depending on actually, if you don't, you might want to try in the first place to find out if Hawks actually, or our homework system, takes that as a correct answer, which I would take if we were taking the exam on paper. Otherwise, well, you may need to go all the way to simplify all this. Now let's look at letter B. So for letter B, f of x equals the square root of x plus 1 over x plus times x. Actually, not plus, times x squared plus 1. Well, in the first place, we cannot just do the product rule just yet. Number one, we need to rewrite these two terms. The radical term, we need to rewrite it in rational exponent form, and this 1 over x, we need to rewrite it in the form of negative exponent. So that's what we're going to do. So this is not calculus yet, this is still just rewrite it. That's an x to the 1/2, and that's plus x to the negative 1 times x squared plus 1. So we're ready to do the product rule. So let's see. The derivative of f, that is f prime of x, well actually, well let's call it f prime because it was given in the f version. So that's the first function, x to the 1/2 plus x to the negative 1 times the derivative with respect x of x squared plus 1 plus the second function, x squared plus 1 times the derivative of the first function with respect x, which in this case is x to the 1/2 plus x to the negative 1. So we just set up the formula to find the derivative of this function. Let's take the derivative. So that is f prime of x equals, so that's x to the 1/2 plus x to the negative 1 times the derivative of x squared minus 1, which will only be 2x, and plus x squared plus 1 times the derivative of x to the 1/2, which is 1/2 x to the negative 1/2, because here what we're applying is the general power rule. Subtract 1 from 1/2, you get negative 1/2. And x plus negative 1, x to the negative 1 minus 1, that's a negative 2. Okay, so we're good to go and keep simplifying all this. Well, number one, well, let's not clean up the signs and well, actually the powers, because we are going to FOIL this. So let me leave all this. Let me actually change that to a minus simply. All right. So let's see. We're going to FOIL this. That is x to the 1/2 times 2x. Well, that's going to give us 2x to the 3/2. So where is the 3/2 coming from? Well, this is x to the first power. When we multiply these two x's, the exponents add. 1 plus 1/2, that's 3/2. And well, over here we're just going to have a plus 2, because here when we multiply x to the negative 1 times x to the first, we have the same base x, but we add the exponents, and in this case negative 1 plus 1, that's going to be 0, and x to the 0 is 1, which is 1 times 2 and equals to 2. And we're going to do the same over here. X squared times 1/2 x to the 1/2, and x squared times x to the negative 2. A very similar situation will happen over here, where, well, number one, that's a 1/2 x to the 2 plus negative 1/2, or in other words, 2 minus 1/2, that is 4/2, minus 1/2, that is 3/2. And then over here again, x squared times negative x to the negative 2, same base, we add the exponents, but 2 minus 2 in this case will be 0. And well, when we multiply, well, let me do this on the side just so it's more clear. X squared times x to the negative 2, that's the same as saying x to the 2 minus 2, which is x to the 0, which equals simply 1. So that will be plus 1, or rather minus 1, because there's a negative, there's a plus times a negative, and one more to distribute. 1 times these two, they don't change the sign, so that's a plus 1/2, x to the negative 1/2, and minus x to the negative 2. So in this case, we're good to go and simplify any like terms that we may have. You know, so for example, it looks like we have this x to the 3/2 and x to the 3/2. We can also combine 2 minus 1, and the remaining two there, just totally different powers. So let's combine this together to give us 2 plus 1/2, so that'll be 5/2, x to the 3/2, and what else? So the next power, well, I'm going to write 2 minus 1, that's going to be plus 1, and plus 1/2. X to the negative 1/2. I'm going to write this x to the negative 1/2 instead with positive exponent. 1 over 2x to the 1/2, and minus 1 over x squared. So from here, we're ready to go back and rewrite this 2 into radical form. So our homework system might take this as an okay answer, but in the case that it doesn't, well, let's go ahead and rewrite this in radical form. Recall that when we have x to the m over n, the denominator of the rational exponent is the index of the radical. That is, we are going to rewrite those 3/2, x to the 3/2 in terms of radical form. So let's see what we're going to get. So f prime, that equals to, let's see, that's going to be, well, that's a 5/2 x, or rather the square root of x cubed, plus 1 over 2 root of x minus 1 over x squared. Final answer. That's our final answer for this one. And well, just like the product rule, we're going to look at another rule, the quotient rule. Well, in this case, there's a little typo here. This is supposed to be division, not product. And well, the derivative of a product will be somehow similar to that of the what's it called, the product rule. But in this case, be careful, because for the difference that we have over here, that is the subtraction that we have here, we call that the difference, the order matters in the subtraction. So be careful not to mix this up. All right, because if you do it the reverse way, you may get and you will actually get an incorrect answer here. So to differentiate quotient, what we do is differentiate the first function times the second minus the derivative of the second times the first one. But in this case, we square the denominator function, that is the function in the denominator of the original function. So let's go ahead and use the product rule. Well, this is supposed to say quotient. Yep, quotient. Yep, your PDF file when you're watching the video should be updated with these silly typos. Okay, so let's find the derivative of the function. Well, so we have y equals, well, so that's y prime equals, okay, so g, which is the denominator function, that is 5x plus 1 times the derivative with respect x of the numerator function, which is x squared, which is this one. All right, minus the function in the numerator, which is x squared, times the derivative of the function in the denominator, which is the derivative. I mean, maybe at this point you can take the derivative in your head, but it's okay to do this notation just so you can see what are we doing and where is everything coming from. Of course, later with more practice you should be able to do this even in your head, but I mean that's not gonna happen until later when you get more practice with this. So 5x plus 1 quantity squared, which is this quantity in the denominator here. So let's start by simplifying all this. Well, we need to compute the derivative of x squared, and we also need to compute the derivative of 5x plus 1. That's what we need to compute. Well, so that's going to be 5x plus 1 times the derivative of x squared, which is 2x, minus x squared times the derivative of 5x plus 1, which is 5. So let's go ahead and do the following here. Of course, keep the denominator squared. So over here, we will distribute and multiply these two. So that'll be y prime equals to 5x times 2x, which is 10x squared, plus 2x, minus 5x squared divided by 5x, plus 1, quantity squared. And we'll keep simplifying to get the following. Well, notice the like terms right here. These two are like terms. 10 minus 5 combined to give us 5x squared plus 2x divided by 5x plus 1 quantity squared. So this is final answer. All right, let's look at another example here. Well, one that involves let's see, actually there's a little typo that I would like to fix here. I would like to change this square root of x into a 1 for a big reason. You will see why. So I'm going to do this problem right here, the derivative of y of the function y equals 1 over 7x cubed plus 4. So on the one hand, well, this is maybe I should have denoted this our function f and our function g from the formula for the derivative of the quotient rule. So this will be our f and this will be our g. So in this case, well, let's see. We're gonna do the following. So that's gonna be y prime equals the function in the denominator 7x cubed plus 4 times the derivative with respect x of 1, that's the function in the denominator, minus 1, which is the function in the numerator, times the derivative of the function in the denominator, 7x cubed plus 4. The whole thing will be divided by the denominator squared. So in this case, well, 7x cubed plus 4 times the derivative of 1. The derivative of 1, the derivative of a number is simply 0, minus 1 times the derivative of 7x cubed plus 4, which in this case will be 7 times 3, that's 21x cubed minus 1, that's x squared. The derivative of 4 is 0. Now, over here, this 0 times that quantity will cancel this term. And then the denominator remains 7x cubed rather, plus 4 squared. And leaving us with, in this case, y prime equals to negative 21x squared over 7x cubed plus 4 squared. Final answer here. So yes, so we're going to look at a problem like this later in the next section using a slightly different strategy called the chain rule, because in this case, well, what I would like to compare later in that section is that sometimes, yes, here we are seeing the quotient of two functions, and well, the quotient rule may be a little bit too much, and the next strategy or the next technique that we're going to learn, which is the chain rule, in the next section will be a lot quicker to differentiate a function like this. In the meantime, let's look at another type of problem. Notice in this case, they're not giving us the explicit forms of each function here. They're just telling us that we have two functions that are differentiable functions, right? And they're telling us that the original function evaluated at 5 equals to 10. They're telling us that that a second function evaluated at 5 equals negative 3. They're telling us that that the derivative of the function f evaluated at 5 equals 1, and they're telling us that the derivative of the second function g evaluated at 5 equals 8. In other words, they're giving us the position points 5, 10, 5, 1, but they're also giving us the rates of change at those points, or the derivatives at those points, or the slopes of the tangent lines at those two given points in yellow. So interpret this as yellow to be points, and interpret the purple highlights as derivatives at those 2 points, right? So let's see. Let's use this information to find the derivative of h. So we're going to differentiate h at 5, given that, well, we have the function defined into different forms. In other words, for letter A, notice that we have a quotient of two functions, so f and g are put together into a quotient of the functions. In other words, this is what we do. Take the derivative of h prime, and well, to differentiate a quotient, what we do is g of x times f prime minus f of x times g prime. The whole thing divided by g squared. So now we are going to put values in here. So we're going to evaluate h prime of 5. That is h prime of 5. And let's plug in 5 wherever you see the letter x. So this is g of 5, f prime of 5 minus f of 5, g prime of 5. The whole thing divided by g of 5 squared. And well, all these pieces of information are given at the top. We're given f of 5, g of 5, f prime of 5, and g prime of 5. Let's just substitute these values wherever they correspond. So g of 5, it's given to be -3 times f prime of 5, which is 1, minus f of 5, which is 10, times g prime of 5, which equals to 8. The whole thing divided by g of 5 quantity squared. So let's simplify these values to get h prime of 5. And this will be, well, so -3 times 1, that's a -3, minus 10 times 8, that's a -80. And divided by, this is going to be 3 squared, -3 squared, which is 9. And well, this is going to tell us that h prime of 5 equals -83 over 9. And well, this cannot be reduced to further terms because 83 is not a multiple of 9 nor a multiple of 3. All right, let's look at the next and last example for this video. So now we have h of x defined in a slightly weirder way. So in this case, we have number 1. It's important to observe here that we have the product of two functions. In a way, we have some explicit forms, but not like all the way, So let's call this the first function. So because we have the product of two functions, we're going to do the following. H prime of x, use the product rule to, okay, so that's f of x plus 3x minus 1 times g prime plus g times, well, actually, let me use the other notation for the derivative to make more sense out of this. Plus g of x times the derivative with respect to x times f of x plus 3x minus 1. All right, oops. So, okay, let's this one right here. This is, okay, differentiate g of x. This will simply be, well, the first factor remains the same. This will become g prime of x plus g of x times the derivative of this expression here. Well, the derivative of f is going to be f prime. The derivative of 3 will be 3, and the derivative of -1 will be 0. So now we have an expression, a differentiated expression to simply go about and plug in, evaluate again the quantity in green, h prime of 5. So h prime of 5, and plug in the number 5 whatever you see the letter x, like here, 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 and here. So let's see what we get. So simply plug in whatever you see the x. That's going to be f evaluated at 5 plus 3 times 5 minus 1 g prime of 5 plus g of 5 times f prime of 5 plus 3. And well, all this information like f prime of 5, f of 5, f prime of 5, what else? The derivatives for g, g prime of 5 and g of 5, well, we are giving all these values. So let's go back to the top to get or to retrieve those values. Well, what is f of 5? F of 5, which is 10, 10 plus 3 times 5, which is 15, minus 1. Okay, so let's put arrows to indicate what we are getting here. And then that times g prime of 5, but g prime of 5 equals to 8. Let's indicate with an arrow. Where is that coming from? Plus g of 5. G of 5, which is negative 3. Which is this quantity right here, times f prime of 5, and f prime of 5 equals to 1 plus 3. And well, let's just simplify this quantity. H prime of 5 equals 10 plus 15, that's 25. 25 minus 1, that's 24, times 8. And 1 plus 3 equals 4. 4 times negative 3 is negative 12. So minus 12. So let's see what we get. So 24 times 8. Do it on the side. 8 times 4. 2 carry 3. 8 times 2, that's 16. 16 plus 3 to 19. 192. And then 192 minus 12. That's going to be 180. And that's h prime of 5 defined this way. And this is final answer, and this is also the end of this video. So for the next video, we're going to cover the chain rule.